Hello friends, Mr. Burrell here. We're in this lesson going to be talking about simplifying exponential statements. We've been talking a little bit about how to simplify different kinds of exponential expressions, how to combine them together. Specifically when I'm multiplying bases, similar bases that have different exponents, or dividing exponents, or when I'm talking about like negative exponents or zero exponents, or when I have fraction exponents. We've talked about how to manipulate exponential expressions in a lot of those forms. So today, we're going to extend that just a little bit and talk about simplifying these different kinds of exponential statements. So by the end of this lesson, this is what you will be able to do. Know what it means for an expression to be in simplest form. When I say that, you'll be able to know what that means. And then you'll be able to simplify expressions involving radicals and or rational exponents. Okay. That's what we're going to be able to do today. Know what it means for an expression to be in simplest form and simplify expressions including radicals and or rational exponents. Again, rational exponents meaning like fraction exponents when I have exponents that are fractions. So, we just recently discussed how we can convert from exponential to radical form and vice versa. So we talked about how something in exponential form, like this, if I had like x to the 2/3 power, I could write that in radical form where the number in the bottom becomes the index on my radical, or this root, and the number on the top becomes the power. So I've talked about how I can convert back and forth. Now, let's practice simplifying expressions in both of those forms. Well, when I have an expression in this form, like a square root or a cube root, we already know how to simplify those. We devoted an entire few lessons to it. So how do I go about simplifying, writing the square root of 45x in simplified radical form? Well, I start by finding the prime factors of 45, which is 9 times 5. 9 is 3 times 3. So the square root of 45 can be written as the square root of 5 times 3 times 3 times x. Okay? And then remember, in a square root number prison, my prime factors have to escape in pairs. So like these two 3's will try to escape, but only one will survive. So a 3 gets out, and the 5 and the x that are left on the inside multiply, so I'm left with 5x on the inside. So like my final answer would be 3 times the square root of 5x. The cube root of 24x to the 4th, I break down 24 into its prime factors like so. 12 times 2, 4 times 3, 2 times 2, which would give me the cube root of 3 times 2 times 2 times 2 times 4x's, x, 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 x. And then in a cube root number prison, my numbers have to escape in trios. Boom, boom. Only one survives in each trio. So the 2 and the x escape, and then the 3 and this x are stuck on the inside. So we know how to do that. We know how to simplify radical expressions, square roots and cube roots. So now what about an expression like this? What if I had something like this? 49x to the 4th to the 1/2 power, or 1000x to the 3rd to the 4/3 power. How do I go about simplifying those? Well, in this form, it might not be as intuitive. It might not be as easy to recognize how to simplify them. So, since we know how to simplify radicals, or like square and cube roots, let's convert this fractional exponent, this exponent that's a fraction, into radical form. Because I can do that, right? 49x to the 4th to the 1/2 power is the same as writing the square root. Remember, the number in the bottom becomes the root. So this is a square root of 49x to the 4th. It's to the 4th power. And then this top number becomes the power over here. So this is the square root of 49x to the 4th to the 1st power, or anything to the 1st power is just itself. So this is really just the square root of 49x to the 4th. In our last lesson, that was all we were doing. We were just converting from exponential to radical form. But now, this is something that I can simplify. Let's see, if I break down 49, I get 7 and 7. So the square root of 49x to the 4th is 7 times 7 times x times x times x times x. And then in a square root number prison, they have to escape in pairs. Conveniently enough, I have an even number of pairs here. So only one 7 survives, one x survives, one x survives. So my answer is 7x squared. There's nothing left in the prison, so I don't need to write it. So my final answer is 7x squared. And that's it. What about this one? 1000x to the third to the 4 thirds. Well, again, with this fraction exponent, it's a little bit harder to know how to simplify it, so let's convert it to radical form. So I'm going to have my radical, my 1000x to the third. That was kind of a big radical. So this bottom number is going to become the index. This top number is going to become the power over here. Okay, well, ignoring this power for a minute, let me put this power aside for a second. The cube root of 1000x to the third, I can do that. I know how to take the cube root of something. Let's break down 1000 into its prime factors. Well, let's see, 1000, let's divide it by 10. That's 100 times 10. 10 is 5 times 2. 100 is 10 times 10. Each of these 10s is 5 times 2. So the cube root of 1000x to the third, I have 3 5s and 3 2s. So 5 times 5 times 5 times 2 times 2 times 2. And then times x times x times x, because I have 3 x's. Well, in a cube root number prison, they have to escape in groups of 3. This is a cube root, right? They have to escape in groups of 3. But only one survives in each group. Okay. Well, when I multiply all those together, I get 5 times 2 times x, which is 10x. So is that my final answer? Is 10x my final answer? No, it's not. My original question was 1000x cubed to the 4 thirds power, so when I converted it to a radical, that was the cube root of 1000x to the third to the 4th power. So this 10x I have to convert, or I have to take to the 4th power. I have to take that to the 4th power. Okay, let's do that. 10x to the 4th power is 10x times 10x times 10x times 10x, right? To the 4th power means I'm multiplying it by itself 4 times. So 10 times 10 times 10 times 10, or 10 to the 4th power. Let's see, that's going to be, let's see, 10,000. I have 4 zeros here. 10,000, and then x times x times x times x is going to give me x to the 4th. So my final answer there is 10,000x to the 4th. Okay? 10,000x to the 4th. Let's do a couple more. Let's go ahead and take a look at this first one. 49r squared to the 3/2 power. So again, with the fraction exponent right now, we're not quite sure what to do. So let's go ahead and convert this into radical form. So under here I have 49r squared. Out here, the number in the bottom becomes the root, so this is a square root. The number in the top becomes the power. So this is the square root of 49r squared to the 3rd power. So let's take the square root of 49r squared first. 49 is 7 times 7. So if I take the square root of 7 times r times r, remember they have to escape in pairs. Only one survives. My answer ends up being 7r. But that's not my final answer, yes? I still have this cubed, this to the power of 3. So my answer is 7r to the 3rd power, which is 7r times 7r times 7r. Something I'll see some students do is they'll just take like this r to the 3rd power and they'll write their answers like 7r cubed. But since this whole thing was originally in parentheses, right, this whole thing needs to be taken to the 3rd power. So, 7r times 7r times 7r, well, 7 times 7 times 7 is 343. And then r times r times r is r cubed. So 343r cubed. that would be my final answer. Let's do one more. 64r to the 6th to the 2/3 power. When I convert that to a radical, I have 64r to the 6th under here. The number in the bottom becomes the root, so this is the cube root. The number in the top becomes the power. So when I'm finished, I'm going to square it. Well, let's find the cube root of 64r to the 6th. 64 is 32 times 2. 32 is 16 times 2. 16 is 4 times 4. Each of these 4s give me 2 times 2, yeah? So that's the cube root of 2 times 2 times 2 times 2 times 2 times 2. There's 6 of them. And then r times r times r times r times r times r. 6 of those. Well, the cube root means they have to escape in groups of 3. So I have an even number of groups of 3 here. Only one survives in each group. So I'm left with 2 times r, which is 4r squared. But that's not my final answer. This whole thing was still taken to the second power, or squared. So my answer is going to be 4r squared, or to the second power, which is 4r squared times 4r squared. Well, 4 times 4 is 16. R squared times r squared, if we reflect back to what we were talking about when I'm multiplying exponents with the same base, r squared times r squared, that's going to give me r to the 4th, right? So this is 16r to the 4th. And that would be my final answer. So that's it. Hopefully you know what it means for an expression to be in simplest form, with no more parentheses, no more radicals. That's what it means for it to be in simplest form. And hopefully you have had a little bit of review in simplifying radical expressions and being able to simplify rational exponents by converting them into radical expressions. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.